So today, our expert is Duncan Duncan McKay. He's a product manager. Duncan is a product manager for the high-level design tools. Um, this includes oneAPI, DSP Builder, and our HLS compiler. Duncan has 25 years of experience supporting customers with using tools such as these. And throughout his career, he has evangelized, employing HLS in design flows, and this includes authoring training, documentation, and design examples highlighting the use of the tools. This also includes being a contributor and manager at 3 HLS startups. And as it says, he's really focused on making sure the tools that we have are of the highest quality and while still being easy to use. My name is Marlon Price, and I'm going to be the moderator for the session. So if you have questions, I'll do a short just introduction to the topic, and then we'll just open it up for questions. If you have a question, you can use the audio, just unmute yourself and ask the question. Otherwise, you can ask the question via the chat. And then I will sort of organize and relay the message or relay the question to Duncan. I also have some questions that were submitted prior to the session, and so I will try to intersperse those questions throughout. The ground rules, any question that you have on the oneAPI or the oneAPI when targeting FPGAs is fair game. Again, over the audio or in the chat, either way is fine. If it's a detailed design specific question, we'll try to generalize, we'll try to answer as much as we can, but if it gets too deep into a specific use case, then we may not have enough time to cover it during this session. And so if that's the case, we'll try to follow up with you after. The goal is to address as many questions as we can during this session. And if the question goes beyond the scope of this, or is more deep, more into a specific design situation, we may end up pointing you to other support resources, FAEs, community forums, and so on, if they may have to address it there. So oneAPI is a flow for accelerating our software code. There are two flows that are supported with oneAPI. The FPGA acceleration flow and the SYCL HLS flow. The FPGA acceleration flow is targeted for accelerating software. So the goal in this flow is to implement a particular function, algorithm, kernel on the FPGA as a accelerator of a larger system. The HLS SYCL flow, the goal of this flow is to produce a hardware IP. But both use the oneAPI SYCL as as the source for this flow. They both produce RTL. They both go through a simulation and a process by the Quartus software. The difference is in the implementation. Again, the FPGA acceleration flow is producing a design that's going to be a part of a larger system, whereas the HLS flow is producing an IP that will get integrated into a larger FPGA design. So the focus of this talk today is particularly oneAPI when used in the SYCL HLS flow. When using this flow, the goal then would be to compile the source using G++ or either in Linux or Windows, and the Intel One API based toolkit, and using then compiles into hardware using the Quartus software. Quartus software. So we have a design methodology that we use when we follow this flow, and those 6 steps are shown there, and I'll just go through those really quickly. So first, we validate with emulation. This is a way to make sure that the algorithm is functionally correct. Um, it basically creates a executable model of the HLS code, and with that, it can test your algorithm much quicker than converting it into RTL and doing the and processing it there. So this would be the first step to basically ensure that your code is functionally correct. Then the code can be converted into RTL. So we have RTL automatic generation. The IO, we automatically generate IO ports. So there's different port types, that's what's shown here, that we can generate for the IP based on the constructs in the code. And those are controllable by the way you code. And then the kernel itself within the code is converted into, IP hardware resources inside of the IP. So your code is automatically generated, the clock speed is defined, um, and it's automatically optimized um, for the target FPGA. We can quickly target any of these supported devices. So shown here, any of our current series families can be targeted with a single code base. So basically, when when generating the code, it's just a quick argument in the function call to specify the target device, and then automatically the HLS compiler will generate the code for that specific device family. Automatic optimization. So automatically the software will optimize for performance, optimize for area, optimize for latency, and those can be done through very easy to use calls when you're generating your code. But for those that want more detailed control over the actual hardware that's being generated. So for example, the memories that get generated, um, how loops are handled, there are manual overrides that can be specified in your oneAPI code if you want more lower level control. And then for once you have your functionality specified, you have very easy way to check the outputs of the tool using easy to use reports. The reports will show basically the HTML reports that are generated that will allow you to analyze throughput and latency. You can see clock frequency performance for the blocks. You can see, if there's bottlenecks in the data flow, how your memory structures are generated. So you can get, again, a more detailed look of the design without going through the full compilation results within Quartus. And then with the oneAPI HLS flow, we also make it very easy to do RTL verification, whereas the tool will generate a self-checking RTL test bench. So essentially, the kernel code within your oneAPI model will be generated into hardware, and the rest of the oneAPI code will be used to create input stimulus for that model so that you can via a test bench, so you can take it into any standard simulator and verify the RTL as well. Once you're done there, the tool will generate an IP block that can be imported into Platform Designer, and from there it can be connected to the rest of the FPGA system. Okay, so that's a quick introduction there. Let's open it up for questions. Any questions for Duncan? Do you want to say anything before we open up for questions?
No, just first of all, say thank you, Marlon, and secondly, yeah, just say hi everyone. Yeah, let's have your questions.
Okay. Any questions for Duncan? Right.
Hello, can you hear me?
Yeah.
Yes.
So one of the slides mentioned memory optimizations, but it's kind of gone over fairly quickly. Is there like documentation available that kind of goes over these memory optimizations and how to use them and best practices?
Yes, there is. In fact, let me just share my screen just a little bit. Sorry, Marlon, I'll take over a second.
That's all right. Go ahead. Take over.
Let me know if you can see my screen now.
Yeah.
Yep.
Yeah, so as you can see now, we have a memory Intel oneAPI FPGA handbook. So everything associated with using FPGAs with SYCL and oneAPI is all captured in a single document. And you can see down here, there's all the memories, an entire chapter devoted to it. So you just search for Intel oneAPI FPGA handbook, you should be able to find those details.
That's awesome. Thank you.
Yeah, and those just round out. So those memory optimizations, they'll allow you to take, say for example, an existing RAM as part of the fabric, and make the software treat it as maybe 3 separate RAMs or 4 separate RAMs or however many. You can partition it up. You can also partition it up by bank, and then you can also take multiple RAMs and merge them together so that the actual function or the software sees it as a single large RAM as well. So there really is multiple options. More options, I would say, you'll find in any of the competing tools. And you can literally do just about everything you can do with RTL. I won't say everything because RTL engineers can do a lot, but yeah, I bet you'll find you can do just most things there. Okay.
Thank you. There's a question in the chat. The question is regarding Cyclone 5 FPGAs. Since oneAPI is compatible with Quartus Pro, it assumes, what about simulating IP targeting Cyclone 5 if that's not currently supported with Quartus Prime Pro? Is there an issue there?
What's this? I assume simulating IP. No, the simulation should work. Yeah, there shouldn't be any issue with that. So as you'll see, maybe in that earlier diagram Marlon showed, when you install Quartus, you can also install Questa, the RTL simulation product that goes with it. And then you should be able to take that RTL and just simply run it. Yeah, I don't believe, I think it is supported.
Yeah, typically RTL is RTL.
Yeah.
And while Quartus is particular about the devices that it targets because it has to build the hardware, the simulator doesn't have that same restriction. So yeah, that shouldn't be an issue.
Yeah, the only thing I'd add to that is, yeah, you should be aware that there's a free version of Questa and a paid version of Questa. You can install either one you choose, and yeah, obviously the paid version probably has more functionality and runs faster. I'm not an expert on those versions of Questa, but just to let you know, there are different versions.
Any other questions? If not,
I
I'll
have
go
one.
to one. Okay, go ahead.
Sure.
does this IP authoring configuration support streaming data? Like if I have a buffer that is continuously being populated, can I have a SYCL kernel process, do operations on that buffer as the data comes in? And in particular, like what does this look like when you export it to Platform Designer?
Yeah, so the streaming interfaces are now supported. Just to let you be aware, yeah, up until about, I think, 2 releases ago, we didn't have that support, but they are fully supported now. And yeah, the directory, the output directory created oneAPI is actually compatible with Platform Designer. So if you just sort of point to that directory, it'll view it as a component, and you should be able to just bring it in. The other thing I'd point out, let me just reverse a slide or two. On our GitHub, there are a number of tutorials, and you'll actually find there is a Platform Designer tutorial. And actually, there was all the way from the SYCL IP all the way through to implementing the software. And alternatively, I just have some backup slides here, guys. On YouTube, you'll find a number of videos. First of all, you can either get started with Windows, Linux, or Windows. And then you can go from debugging code to synthesis to reviewing the RTL. And this final slide I'm showing here, or this final video, this is actually just a video version of that tutorial. So you can actually see how we go from SYCL IP all the way through to importing the IP into Quartus. And I believe that example does show a streaming interface. Okay. Don't quote me 100% on that. It's been a while since I checked it and used it, but I think it does show a particular interface. But SYCL, the streaming interface, I meant to say, but streaming interfaces are indeed supported. Okay.
Thank you.
Cool. I'm just going to ask to answer your question, but thanks. Any other questions, anyone? While I'm waiting, so you can actually see that slide up there, everyone. This blog actually has links to a lot of the getting started material. So while we're waiting for maybe someone else to say something, I'll put a link to that in the chat window. Okay, feel free you can go visit that yourself. Check out those videos and check out links to all those other things mentioned on that slide there. Okay.
I do have a question, Duncan.
Sure.
The question is, when running oneAPI for SOC FPGAs, can we run the host code on the ARM HPC and the kernel on the FPGA fabric?
I think so. Yeah, I don't see any problem with that. Yeah, I don't see it unless anyone else. Yeah, you should be able to do that. It shouldn't be a problem.
No, it doesn't work. The SYCL runtime is not supported on ARM, so it is open source. So you could try to put it together yourself, but with what comes in the package, it doesn't run on ARM.
Oh yeah, sorry, Kevin, you're right. Yeah, that's used in what we call the full acceleration flow. Sorry, I was focusing here on the IP flow. Yeah, as Kevin said, yeah, the runtime actually dynamically won't do that. However, on the other side, in the IP flow, as we're mostly talking about today, if you generate that IP and it has Avalon memory agent interfaces, we'll generate all the driver files from that you can then use with your HPS, the ARM processing system on the FPGA, and then connect it that way. So what I would say in the SYCL HLS flow, yeah, you can create IP and instantiate that IP in the fabric, and then take the software driver files that are generated for that, and then use them with your ARM processor and talk to the IP. But sorry, I got that wrong there. But in the acceleration flow, you can't just use an ARM processor instead of an x86 version, not in today. But as Kevin said, the only thing that's missing there is the runtime, and that is actually open sourced. So we actually have, I believe, we have one customer actually working on that today. They took that open source code and they're adapting it from themselves. And we will look into supporting that at some point in the future. Okay. Thanks, Kevin, for you assisting there.
Okay. One question I got here, Duncan. So, your experience, what are the projects or applications that are best suited for, HLS, the HLS flow?
Actually, HLS is a very horizontal technology. So I would say it's you can use it just about everywhere. There's not really a lot of places where it's limiting. The only things I'd say it's limiting is if you're trying to do like a really detailed type RTL interface where you're doing things on pause and neg edges of the clock. It can't replace that. But to get closer to your question, there are a few places where it is particularly useful, where it excels. I'd say one of the broadest is for classic linear algebra type designs. The first thing about that is those algorithms tend to lend themselves very well to SYCL C code. So you'd just think of a for filter. It's easy to write that summation as a for loop. But the second thing about it is, oneAPI does support arbitrary precision and fixed point data types. So even within those linear algebra algorithms, you can actually write bit accurate C code. And the way you want to actually use the methodology there is to run that C code as often as possible, everyone. Take advantages of one of the great advantages is the verification speed of using C. Now, in the slides there that Marlon showed, you might have seen a reference to like a 10,000x speed up. That may sound unbelievable, but the classic example I would use, everyone, is take a video example. A frame of video in 1920 by 1080. That's 2 million iterations. If you go run that in RTL, you'll know it will take hours. If you compile that code in C and run it, it'll take about 10, 15 seconds. And if you were to do 10, 12 frames of video instead of one, it might take a whole 20, 22 seconds. So it's that kind of speed up, and you can do that with bit accurate examples. So you can really use it on these, a lot of linear algebra type algorithms that works really well. The other place it works very well and where it really excels is if you're, like I just spoke about in that last example, if you have a processor, whether it be an ARM or an XCPU that's off chip, and you're talking to an Avalon memory mapped agent interface or a light interface, oneAPI, it easily deals with that, but also automatically generates all the software driver files that you need to talk to that interface. And so every time you update your IP, you don't have to worry about redoing all that software. It's just generated automatically for you. And that's another great fit. And the last of the three, I would say, is when you're using a code for control-based applications or finite state machines. Now, I think you're all aware maybe of the challenges at RTL of creating a finite state machine, a large and complex one, where you're basically drawing a large bubble diagram and then writing it in RTL. In C code, that's so much easier. You just use if, else, then statements, case statements. And I would say that most people, and then if you change the spec, it's easy. Whereas changing the spec, RTL, is actually a lot of detailed modifications. It can be dangerous. So you can make mistakes a lot. Not dangerous, but you can make a lot of mistakes before you get it working well. But when you do it in the SYCL C++, it manages all the complexity for you. And in my career, I've generally found that when people when they move to using SYCL and C++ for control and finite state machine design, they just never go back to RTL. It really has that big of a, it really takes care of all the complexity for you. So to summarize what I said there, linear algebra type designs will excel. You'll find you get great productivity because it's easy to capture the code and you can stay with a bit of accuracy. Using anything with a lot of CPU talking through the AXE agent interface and using it for control type designs or FSMs. And control type designs could be, reading packets where the decisions after that are really if, then, else if, case switch, things like that. So those applications really excel, everyone. And I think if you use them for those, you'll see some pretty significant productivity boosts.
Going along that, do you guys know if you have an example of using FSM in SYCL in your guys' tutorials, or even using the AXE interface for control designs, as you mentioned?
The AXE interface, there are examples on there of using the agent interface. Try to think of one example. I'm not up to date on all of the examples. I haven't looked at all of them, but let me have a look and put one in there. Most of the, yeah, well, let me have a look and see. Actually, within this this blog post, and you'll see here, maybe I can actually show it. Yeah, here's the example of this blog post. If you scroll down this, it does actually show you our reference examples here. And here you can see they're sort of divided up by market. I'm sorry when I zoom into that, it doesn't actually read very well. But maybe one of these here will suit your needs, like merge and sort, or the database compression, CRC. I need to go double check. Sorry, I don't have that off the top of my head. I wish one of my FAEs were here to help. But yeah, I'll try and, if you actually drop, I don't want you to put your name in there. Let me put my name in the chat window, my email. Feel free to email me and I'll get back to you, okay? I'll answer that question. I just can't answer that off the top of my head. I'm not usually into that level of detail. But there's my email in there. If you want to ask me that question offline, I'll take the action to get back to you and try and answer that question for you, okay? And yeah, sorry, I don't have that off the top of my head. What I would do is I'd go look at some of these SYCL examples here, the getting started examples, and that's how I get back to you and check. But yeah, you look at this blog, you can look at all our tutorials. But yeah, hopefully I'll get back and let you know that. Okay. So sorry I don't have that off the top of my head, but there should be something out there.
That's good, thank you. And then one more, you mentioned the linear algebra. I assume that the Intel math kernel library, MKL, can be ran on SYCL. And I assume those operations make their way to the FPGA when doing IP authoring?
Not all of them. Again, I need to check. I don't think we support the MKL library for FPGA. But in those examples, you can see what we do support. But no, the MKL library doesn't move exactly in FPGA today. Okay. Is there any specific math operator you are looking for in that? I mean, most of the, well, I'd say arithmetic ones are definitely supported. Other ones I need to double check or check in the FPGA handbook.
Thank you.
Is there anything specific you were looking for?
You know, stuff like fast Fourier transforms or
yeah. We have some. Yeah, we have FFTs in there, and actually we have in there. It's called I forget the name of that. Those examples I just showed you there. Yeah, one of them is a matrix multiplier. If I just scroll back and try and read it again, I've lost my link. Yeah, there is a matrix multiplier in there, and there is an example of an FFT. I know these are definitely used today. Okay.
Yeah.
Okay, thank you. Any other questions? Question on the training options. What are the training options for oneAPI?
So we actually have 2 training classes coming up in April, I believe April 20th. I can look at the dates exactly in a minute. April 20th and April 22nd. We have one in EMEA, Europe time scale, 10 a.m. in the morning, and one in the US, again about 10 a.m. in the morning. And I can just, April 20th and April 24th, we will have those training classes set up. So if you're on the Intel mailing list, sorry, I'm just opening my file there to get the exact, sorry, I don't want to share that with you. But just trying to get the example. Yeah, there is a training class Monday, April 22nd in US time frame. I can put this again into the chat window, everybody. But you should have got an email on that, USA time. There's some details on the training class that's coming up. And similarly, we have another version. It'll be on the European time. And again, let me put that in here. Europe time, European time. And that's on, again, I'll put that in the chat window for you all. That's on Wednesday, April 24th. And you can see that's Central European time on that one. So those are available next month at those times. You should have got emails on that. And again, if you didn't, anyone reach out, let me know. I'll make sure you get added to the invite list, or the email will be forwarded to you. In addition to that, as I was showing earlier, sorry, I left that page up there. If you go look on the Intel YouTube video channel, and I believe also in this blog, there is a link. We actually have an online version of one of those classes. It's about 2 hours long. That class is actually focused on the full acceleration flow rather than the IP flow. But I would say, everyone, those classes are about 95% the same, okay? So you could actually attend one of them and still get lots of information. It may not just answer 100% of all your questions, but as something like 95, 97% are the same. So you can also go onto YouTube and go to the Intel FP, the Intel channel on YouTube, where you would find these videos. And again, links for that specific class are found in this blog post as well, that I put the link in there for. And you can actually do it on your own, at your own pace, or look to sign up for those classes that are coming next month, and an instructor will be there to help you, okay, and answer your questions live.
All right. Duncan, a question about Max 10. I guess all the FPGA families were shown on the slide earlier, but Max 10 was not there. What's the story with Max 10?
Yeah, so as you saw earlier when Marlon showed those slides, we support most of the common, I'd say, more modern families, such as both of the Agilex families, both the Stratix, the Cyclones, and the Arias. However, today, yeah, no, Max 10 is not supported. I think it's one of the few we've still left to support, but it is on our roadmap, okay? But just to let you know, that is one of the few that's not currently supported, but hopefully we'll have that covered soon. But yeah, thanks for your question. Appreciate we don't have everything there, but I believe we have all of the modern families. And I think the only thing that Max 10 had was, I think, non-volatile memory in it. So yeah, if you needed that application, we don't support that. My only work around that for everyone is, yeah, you can still generate the RTL targeting one of the other families, but yeah, I'm not sure I'd recommend that flow, but it's a workaround for engineers. You then take a responsibility that you've got to make timing, but yeah, I wouldn't recommend it, but FYI, that's an option. Okay. What about that?
Yeah. Any other questions from the on the phone or through the chat? Not, I will grab one from the. Oh, this is a good one. So what happens with oneAPI when Altera leaves Intel?
So we really have, it's well heard. Hope you all saw the webcast. It was really well attended the other week, where Sandra got up and introduced as being I'm not like that in the corner again, Altera, an Intel company. So really, we have no plans to change oneAPI for FPGAs as we move out, and also we actually don't really need to. oneAPI is actually an open industry standard. I think it is actually very associated with Intel. We're a big proponent of that. But also means, because it's a standard, oneAPI for FPGAs does not require Intel. We will still be an Intel, large majority owned Intel company, even after we IPO in our plan. But yeah, we don't actually need Intel. We just support the standard. The other thing I would say is that, even throughout the whole support for FPGA, what was the PSG group inside Intel, or the Programmable Solutions group that's now become Altera, we've always had ownership of the FPGA part of that product anyway. So the same engineers were working on it previously will be working on it in future. And so from our point, there will be no substantial changes. We'll just still working with the same Intel teams. We'll still be downloading the same code that's been updated and fixed for each release. We'll stay in sync with oneAPI releases. And I fully plan for us to be also be part of that release, so that if someone downloads oneAPI from the Intel site, there'll be an option there to also automatically download the FPGA. So really don't see any changes about how it's going forward. Yeah, Yeah, so I hope that gives you some clarity and some reassurance that, yeah, we will be a separate company going forward, everyone, but really no fundamental changes as per this product, okay, and how we support it. I think that's about it. Yeah, I say if anything, you might see some enhancements of what we can do. As a separate company, we can probably move faster, even behave a bit more like a startup than behave more like traditional Intel. So we're looking forward to that, and hopefully you see that in our roadmap and our support going forward. Yeah, so no particular changes in summary, but thanks for the question. I understand your concern, but it should be good.
Thank you, Duncan. Okay, a question from the audience here.
Anyone else have any questions? Something edgy or exciting?
All right, I'll go to one of the questions that came in previously again. The Visual Studio required a Windows. What about other C compilers?
Yeah, I guess by that you mean, yeah, the first slide there we showed that you can either use G++ on Linux or
Right.
Microsoft Video Studio on Windows. Yeah. So yeah, well, SYCL, everyone, is just basically C++. I mean, it's just it's a modern version of OpenCL. I can go into that in more detail if you like, but yeah, you can basically compile it with any C++ compiler. However, what I would say is if you want to actually use our examples, in which there are a lot, and I was just showing you there a second ago, and I can maybe go forward and show again. So we have lots of these reference designs, lots of these tutorials. I believe there's over 45 tutorials, and I don't know how many reference designs I showed you there. But to use these, we actually require a CMake environment. You know, these are all scripted. These all run, so you can just type make and run them. So the only thing you really need, everyone, is a CMake environment to use our examples, okay? So you can compile, as I said, you can compile SYCL C++ code with any C compiler you want to use. But for a CMake environment, yeah, obviously I'm not an expert on all the various C compilers that are out there. I do know G++ supports it and Microsoft Video Studio supports it. And I also believe Eclipse supports it. You'll also find support for that on our Intel website. But everyone, I wouldn't actually recommend Eclipse. Just over the last few years, it's actually been harder and harder to actually hire developers on Eclipse. So it's what I've seen in the industry is most people are using towards Microsoft Video Studio, and especially VS Code. And a lot of the Eclipse-based tools, they're getting kind of long in the tooth, and they're not getting updated with features as much. So that's why we just find it easier to recommend Microsoft Video Studio. Yeah, but if you install that, mostly what you're wanting that for is the CMake environment so that you can use our examples. But if you don't need to use our examples, I think you can use just any C compiler. But Microsoft Video Studio is free. It's easy to download. And actually, if you download it and install it before oneAPI, the oneAPI-based toolkit, you'll actually find a special Intel menu in there. And you'll be able to use the oneAPI commands either through the menus or through the right-clicking on the Microsoft Video Studio. And alternatively, we didn't actually have it in the front there, everyone, but if you wanted to use VS Code, we also show you in those getting started videos how you can also install VS Code. And from there, you can actually install a couple of Intel SYCL-based extensions, and you can use VS Code. And I personally use VS Code. I find it gives me just a nice little GUI, but also happens to have a command line. And I mean a GUI for modifying the code and things like that. So yeah, that's the only reason we'd recommend Microsoft Studio for the CMake environment, so you can take advantage of our examples. But again, yeah, a little bit of a background and detail on that. If anyone's got any questions on how or why, let me know. If any further questions, I'll be happy to try and answer them. Thanks.
Okay. Yep. Thank you, Duncan. Let's see, I'm going through questions. If anyone has a question, you can go ahead and say that. Otherwise, I'll find another question here.
While you're looking at that, Marlon, I was just going to ask, I mean, the other, rather than just technical questions, anyone, I would also be happy to hear, if anyone's using it today and whether you had any experiences on the ramp up and whether you'd like us to change anything or do anything or ask us why things in a certain way. So feel free to ask even methodology questions or anything about the tool at all. It doesn't always have to be some deep technical know-how. Just FYI. Sorry, Marvin.
Okay.
If there's any others,
no.
Let me know.
Okay. Let's see what we have here. SYCL versus C++.
Oh.
What are the, could you talk about the differences between them?
Yeah, so as I said, I mentioned that earlier. So everyone's SYCL is basically, it's based on C++. So it's basically a C++. The way I describe it, as I maybe said earlier, SYCL is a sort of modern version of OpenCL. As someone else once said, the great quote, but I haven't used it. SYCL is the heterogeneous language we always wanted. OpenCL was used in the past. OpenCL was also based on standard C, so it didn't support a lot of the things like templates and stuff like that. So, one of the advantages of SYCL is it understands the concept of an accelerator. It has this. It understands the concept that in order to the accelerator will not be accessible directly by the host. So it has this concept not just of an accelerator, but of the fact that you could use shared memory between the host and the accelerator. Or alternatively, you would define channels or buffers in SYCL parlance on how to communicate with that accelerator. And that means there's either read, write, or read-write buffers. And I can give you an example of what I mean. SYCL has the built-in concept of a queue. It actually understands a queue. You can actually say .queue, and it understands that you can assign multiple functions or multiple kernels that you want to accelerate to the same queue, and they would map to the same piece of hardware. Say for example an FPGA. But with SYCL, because you didn't have to write that yourself, that comes as part of the language. All you have to do is include SYCL.h. You can actually understand that you can actually assign the same kernel to different accelerators or different queues, and any combination of those. So as a programmer, you just need to say, oh, accelerate that on QA, accelerate this on QB. If this is happening, maybe move that to QC. And rather than having to write all that underlying code to manage that and writing all these semaphores yourself, all that's built into the language, everyone. So it makes it really convenient when building something that you'll have to accelerate one day, whether it's on a GPU, whether it's on an FPGA, or whether it's on your own maybe custom accelerator. SYCL is everything you need to do that built in. The other thing about SYCL is it integrates very easily with oneAPI itself. There's a sort of base metal layer in there. And to that, we as Intel, we can plug in also the OFS or the Open FPGA stack, so that you don't even have to code up the DMAs. So I say that magic of SYCL sitting on top and dynamically handling these queues for you. You just plug in OFS enabled hardware underneath, and you don't even have to worry about the DMAs or write that. So it becomes easier for you, the user, to then just swap in and out different types of accelerator. The other thing I could say about SYCL, just to quickly go, and it was also covered in another blog you'll find out there. One way it's actually talking about how you accelerate genomics, or I forget the molecular discovery. But you'll see an example in there where the user actually changed the code from OpenCL to SYCL. And you can look at their metrics. They said some of the examples are that SYCL is based on C++ 17. It's much more modern. And when they took the SYCL, their old OpenCL code, and moved it to SYCL, it went from about 566 lines down to 285. I'm just reading that directly from the the article I just put in there. So SYCL is actually much more robust. It's much less verbose. Just easier to use, and I would say, yeah, I like that quote. It's the modern version of OpenCL we always wanted, or heterogeneous language we always wanted. So I hope that gives you a summary. You know, SYCL, nothing special. It's just basically C++. But it really has a few. You include the SYCL.h file in there, and it includes a lot of, I would say, like if you're a designer or an algorithm developer, that's what you want to concentrate on. And to accelerate it, SYCL includes all these underlying things you need, like queues and DMAs. And sorry, everyone, you didn't need to know about my one-on-one and things like that. And yeah, that's basically SYCL. If you get any other questions on that, yeah, let me know. But just I usually write SYCL/C++ because I would also say, everyone, if you actually look at this article, and you scroll to the end where the other additional links are, you'll actually find another video I created that shows you how to convert C++ to SYCL, and just it basically explains what a SYCL queue is and how it works together, and how basically easy it is. And FYI, if any of you guys are using some of these new copilots, they also understand what SYCL is. You can actually just ask them to write. I tried an example the other week. Write me a vector add in SYCL, and it comes back and it's all correct and it all works. So just FYI. Yeah, it's just another flavor of C++ that is useful if you want to accelerate things. Sorry if that was verbose, but there you go.
That's good. And what about their DPC++? And
DPC++, everyone. Sorry, Marlon, did I cut you off? Are you going to say something?
No, that's it. That's it.
Cool. Okay. Sorry, I was being too enthusiastic there, but still trying to show manners. Still trying to show manners, everyone. So DPC++, everyone, is I would say is Intel's implementation of SYCL. So it's basically the exact same as the SYCL language you have out there. The only difference is that DPC++ supports additional attributes. So there's attributes you can put in the language that will tell the compiler, the oneAPI compiler, that Intel creates, what to do with those attributes to implement it better in hardware. Okay. Now, let me clarify a few things there. I said the oneAPI compiler that Intel creates. Yeah, that's the oneAPI that you'll download from the Intel website. But that compiler is also still part of the oneAPI standard. Okay. So everything that Intel does to that is uploaded into the SYCL standards. So everything that Intel does, it's then reshared with the entire community through oneapi.org. The other thing I'd say is that, yeah, if those attributes impact SYCL and how the SYCL language is supported, they're also uploaded to Kronos.org and made part of SYCL. So there's really, I would say the only difference with DPC++ and SYCL is that DPC++ supports additional attributes. And if you were to take DPC++ and go run it in someone else's SYCL compiler, and on the Kronos website, you can see that there are many other SYCL compilers out there, including AMD's. They've got one called Tricycle, which is not very advanced, but they're trying. Yeah, that same code will run. It's just that those additional attributes that are in DCC++ would just simply be ignored by the compiler. You just get a warning, that this attribute's ignored, don't understand what it is. That's the only difference. So really not much difference, everyone, just that DPC++ has some attributes in it. And you'll generally find that in my material and some of our documentation, we often just refer to SYCL, but SYCL DPC++, fundamentally the same thing, everyone. So that'd be my message to you. Okay. Just Intel chose to give it a new name because we support additional attributes. Sorry, Marlon, I added additional info again.
No, that's good. Please. That's good. Thank you.
Cool. Sorry.
Thank you very much.
Too much.
Good explanation.
Cool.
We have about 5 minutes left. I just posted a link for the survey in the chat.
Yeah.
Any final questions or any?
Mari, I was going to say, Marlon, if you want to share screen, go ahead again. I stole your screen earlier.
That's okay. But basically, you're showing what I would show, so it's okay.
Yeah.
That's all it's going to show is where you can get additional information.
Sorry. Okay,
That's
sorry.
That's all right.
Cool.
Let me get my presentation back.
Yeah, I've left it up there, everyone, because if you find that log on that blog, I think hopefully I've got most of the resources in there that you need to get up and running. And yeah, my email's there, so reach out to me if you have any issues. And if I can't answer your question, one of the more technical folks, like Kevin, who just jumped in to help me there earlier, I'll get their help. Okay.
Can you move that one slide forward, Duncan?
Oh, sure. That
I
one?
wanted to point to GitHub. Just point it against
yeah.
the GitHub.
Yeah.
Definitely, you know, lots of examples, reference designs. So that's lots of things there to get you started. In addition to the documentation is available up there. Okay, that's any other final questions? That's all I have for questions I received. Any other questions before we end?
Well, I'd like to say thank you, everyone, for taking the time today. If you have no other questions before you. Sorry, Marlon, I just want to get that in there before you.
Yeah, it's okay.
And I appreciate you showing up there, everyone. And again, you have my email. If you have anything offline, feel free to reach out. I got no problem answering your questions. Okay. Sorry, Marlon, back to you.
Oh, so everyone, thank you again for coming. The recording will be available, so you can use that as a reference later. Again, the 2 classes are coming up at the end of April. Feel free to reach out if you have any more questions on those. And other than that, I think we can end the session for today. Thank you, everybody, for coming. Remember to survey.
Thanks, everyone.